All right, you guys, I hope everyone's doing well. This is for my seventh graders. So we are going to talk about some vocabulary terms. Two specifically is the word integer and rational numbers. So an integer are all whole numbers, their opposites, and the number 0. So for example, 2 and -2. 2 is a whole number, -2 is its opposite. 5 and -5, 7, -7, 0 is included in integers, -10, 10. So any whole number. So that does not include decimals and fractions. All right. Now then we're going to look at the word rational numbers, or the term rational numbers. So all integers are rational numbers. So any whole number, their opposites, and 0 are all rational numbers. But then we also are going to add into that category fractions and decimals that terminate or repeat. So not all decimals, but all decimals that end, like 0.5, or repeat in a pattern, like 0.33333, because when you have a repeating decimal, you can write it as a fraction. So really, an even better definition for rational number is any number that can be written as a fraction. All right, which is what I just said. Rational numbers can be written as fractions. So if you have the square root of a perfect square, those are rational numbers because you would end up getting a whole number. So the square root of 25 is 5, which is an integer and a rational number. Square root of 100 is 10. Square root of 9 is 3. So these are all rational numbers. However, if you end up with the square root of a non-perfect square, and I'll show you a list of perfect squares and perfect cubes in a few minutes. If you have a square root of a non-perfect square, those are all irrational. So in other words, if I try to find the square root of 2, what number times itself equals 2? Well, there isn't one. But if you put it in your calculator, it's going to be a non-terminating, non-repeating decimal. So the square root of 5 is a non-terminating, non-repeating decimal, square root of 20, so on and so forth. So for all non-perfect squares, if you're asked to find the square root of non-perfect squares, those are all irrational numbers. Pi is probably the most popular irrational number. Pi is a number that has to do with the diameter of a circle divided by its circumference, and every single time you'll get this number that we approximate to be about 3.14. But really, it goes on and on and on forever. It never terminates and it never repeats. So that is an irrational number. So when we go back to this statement here, rational numbers are any numbers that can be written as fractions. Well, that's true unless they stick a symbol in there. So if you see this fraction, that pi symbol makes this actually irrational. Okay, so when we talk about fractions, we're talking about the numerator and the denominator are integers. So if you have an integer in the numerator and an integer in the denominator, in fraction form, it is a rational number. All right, so we're going to practice writing repeating decimals as fractions. So when you think about this type of problem, you need to think of the magic number is 9. The magic number is 9. So however many digits you have repeating, that's how many 9s you're going to write. So 0.333, how many numbers are repeating? Just one. The number 3 repeats. So we would write 9 over 3. No, I said that backwards. We would write 3 over 9. Now, hopefully you realize, oh, this pen hates the number 9s. I don't know why. But anyway, then you go, oh, okay, well, I can actually simplify this, right? I can divide both of these numbers by 3 and I get 1/3. So hopefully you guys do know that 1/3 is equal to 0.3333. And if you're not sure, take your calculator, divide 1 by 3, and your calculator screen will fill up with 3s. All right, what if I have 2 repeating numbers, 0.45, 45, 45, then that means your denominator is going to be 2 9s. So 45 divided by 99 is 0.4545. So I want you to double check it. I want you to look on your calculator. I want you to divide 45 by 99 and see for yourself that that equals 0.454545. Oh, my solar calculator doesn't show up very good. Right? Well, and then always simplify it when you can. So I know that we could divide both of these numbers by 9, right? So 45 divided by 9 is 5, and 99 divided by 9 is 11. So once again, double check 5 divided by 11, double check it in your calculator. You get this number, 0.45 repeating. All right, now we have 3 numbers that repeat in a pattern, 1, 3, 4, 1, 3, 4, 1, 3, 4. So what do you think? How many 9s are we going to end up with? We're going to end up with 3 9s. Okay, so I don't know if I can simplify that. They're not divisible by 2. They're not divisible by 3. But could be a bigger number. I just don't know what it is. But double check your calculator. Is 134 divided by 999.134134? Yes, it is. So that's how you write. That's why repeating decimals are rational numbers, because you can write them as fractions. Okay. So look at the next statement. Non-terminating, non-repeating decimals are rational. What is an example? Well, we could make up numbers, couldn't we? 2, 4, 0.24675 2 ... Moving on and on and on forever in no particular pattern. Now, don't try to write a pattern that repeats. That you just made it rational. So just, whatever. We could make up numbers all day, couldn't we? So those are both examples of non-terminating, non-repeating decimals, which are irrational. All right, so when you order rational numbers, you want them all to look the same. So the easiest thing to do, so one choice is, if you have fractions and decimals, one thing is to make them all fractions, but all those fractions would have to have common denominators, which could take a lot of time. So the easiest thing to do is to make them all decimals, okay? So let's use our calculator and figure out what these numbers are as decimals, all right? So -5.6, I just put it in my calculator, and I'm going to put them over here. -0.08333 forever, okay? That's the first one. And then, of course, we have -5. -5 is a whole number. So if I added numbers after my decimal, they'd all be zeros. Now, the next one, we don't know what it is, but hopefully you guys have this calculator, this Texas Instrument Multiview 30XS, and there's a radical button, a square root button, which is just over the x squared. There's a radical right in there. So I'm going to hit second, and I'm going to hit that radical button, or excuse me, that x squared button. And on my calculator, I see a little radical, and it's flashing inside. So inside that radical, I'm going to type 26 and then hit equals. And then to make it a decimals, I'm going to hit the double arrow button. So when I hit that double arrow button, it turns my square root 30 or 26 into a decimal. And of course, it's got a negative sign in front of it. So it's actually negative 5.0990 ... It goes on and on forever because it's irrational. And then the last one, which is -31 divided by 6, and my calculator, it tells me I get -5.1666 ... forever. Okay. All right. Now remember, oh, that was terrible. Let me try to make a semi-straight line. So when we talked about the number line earlier, we talked about numbers farther to the right are larger. The farther you go right on a number line, the bigger the numbers are, right? So if this is -5, ooh, look at that. Oh my gosh. -6, and so -1 will be about right here somewhere. All right, so this first number would be between 0 and -1, correct? So this is about -5/6. All right, and then we have -5, which is here. And then this is going to be closer to -5 than -6. So this is -√26. And then this number is going to be about -31/6. Are you with me? So the farther right, the bigger the numbers. So the smallest number on this list is -31/6. That's the smallest. And then we have square root or negative square root of 26. And then we have -5. And the biggest number on this list, the one furthest right, is -5/6. So they're actually in opposite order. They were actually listed greatest to least. We want them least to greatest. All right, that's a lot of mess, isn't it? But anyway, this is the right answer. This is the answer. And the best way to do it is turn it into decimals. All right, let's get rid of all this stuff and go to the next one. All right, so we're going to use our calculator. We're going to say, what is 14 divided by 9? So this number right here, we're going to line them up 1.55555. This is a repeating decimal. Square root 7, I'm going to use my second button. I'm going to use my x squared button, and I've typed in 7 equals or enter, and then double arrows. So this number is 2.645 blah, blah, blah. And then 4 to the third power. So 4 raised to the third power, 4 times 4 times 4 is 64. So 64.000. Square root 13, second x squared button. Whoops, I put in the wrong number. Square root 13 is double arrows 3.60555. And then square root 40, I get double arrows. I'm going to get 6.324, so on and so forth. All right, so what's my smallest number? So I'm checking, so obviously this is my biggest number for sure, right? So now I'm checking the ones places. Checking the ones places, I'm comparing 1, 2, 3, and 6. So my smallest number is the first one, right? So my smallest number is 14/9. So that one's gone. All right, now I'm comparing these other 3 problems, 2, 3, and 6. So square root 7 is my next one. And then square root 13. And then square root 40. And then of course the biggest number, 64, which is 4 to the third power. This is my answer. All right, let's do the last one. Actually, you guys try it. Pause the video, figure them all out in decimals, and then write the answer. Come back and check your answers. All right, so -7 divided by 4 is negative. I'm going to put them up here. So -7/4 is equal to -1.75. All right, we know the square root of 4 is 2, positive 2. We know that pi is equal to 3.14159, blah, blah, blah. And then 2 divided by 3 is 0.666 repeating, right? And then square root 3 is 1.732, 1.73. And then we have 0.4545. And then 2 4/5 is equal to 2.8. And then the last one is 0.563, so on and so forth. Oh, these say rational numbers, but that last one's not rational, or nor is pi. So anyway, my bad. It should, Oh, we're just circling these. Oh my gosh, you guys. I didn't even read the directions. That's what happens when you don't read the directions. You do too much work. All right. So anyway, we could order these now, right? This one would be the smallest. That's the only negative number. And then we would have 0.5 is smaller than 0.6. Oh, actually 0.45 would be next. Anyway, if you ordered them, let me know and we'll check each other's answers, okay? All right, so the directions say circle the rational numbers. So rational numbers are numbers that can be written in fraction form. So this is a fraction, that one counts. This is a perfect square. That one is definitely not rational. Here we have a fraction. That one is rational. 3 is a non-terminating, non-repeating decimal, so it's not rational. If you have a repeating decimal, you have a rational number. This one's rational, and the last one is not because it goes on and it doesn't have any kind of repetition. Okay, so next time, Ms. Richardson, read the directions. All right, so that takes us to our discussion on perfect squares. So all of these numbers listed on the right side are considered perfect squares. And it's because if you take a whole number and multiply it by itself, you get these products. So for example, 6 times 6 is 36. 36 is a perfect square. The square root of 36 is 6. So that's how we think of perfect squares, all right? So this is asking us questions. What is the square root of 36? So the answer is 6. What is the square root of 144? Well, right here it tells us that 12 squared is 144. So the square root of 144 is 12. What is the square root of 81? The answer is 9. What is the square root of 169? Find it on your list. It's 13. What's the square root of negative 25? Well, I know the square root of 25 is 5, right? So let's see. Is there any way we could get negative 25? Well, I know that 5 times 5 is 25. Well, let's try negative 5. Negative 5 times negative 5. Last week we learned that if we multiply two negative numbers, we get positive. So there's no way to get the square root of a negative number. So it's not that it's irrational. This actually does not exist. There is no solution. If you type that in your calculator, if you do the square root sign and inside of it, you do negative 25, your calculator will tell you you've made an error because there is no number times itself that equals negative 25, okay? Now, however, look at the next problem. This one is different. This is asking, so anyway, the answer to this is no solution. Okay, so this is, I'm going to write NS as in no solution. And when you get to 8th grade, you'll have math problems that involve equations that have no solution. All right, now this is saying, what is the square root of 25? And we know the answer is 5. And then it asks, what is the opposite of the square root of 25? So this is a real answer. Okay, so if you have that negative sign in front of the radical, that's a real number. If it's inside, it's not a real number. All right, so then let's think of it the opposite way. If the square root of 81 is 9, then what would be 9 squared? 9 squared would be 81. So what's 7 squared? Well, it's on your list over here, right? So 7 squared is 49. What if I have negative 3 squared? Negative 3 times negative 3. A negative times a negative is positive, positive 9. 4 squared, we have 16. And what else? Negative 10 squared, negative 10 times negative 10 is positive 100. All right, so then we have this little equation right here. It's basically asking the same thing that the right side of this slide is asking. It's asking what number squared equals 49. So it wants you to find the missing number. So what number would go here? Squared would be 121. Well, there's actually two answers. X is actually equal to positive 11, but also negative 11, because a negative 11 squared is also positive 121. So we could write the solution as the positive and negative value of 11. All right. What number squared is 4? Well, we have two answers. Positive 2, almost wrote that too small. Positive 2 and negative 2. The positive and negative value of 2. What number squared is 144? 12, right? What number squared is 14? 4 and negative 4. Now, normally people just expect the positive number answer, but technically there are two answers, okay? Now, these are all imperfect squares, which means they're all irrational, excuse me. All non-perfect squares are irrational, but we can estimate the answer, okay? So if we had a number line, and I started with 0, 1, 2, 3, let's go a little bit higher, 4, 5. All right, so if I asked you, what is the square root of 25? You would tell me the answer is exactly 5. If I asked you, what is the square root of 16? You tell me 4. This is the square root of 9, and this is the square root of 4, and this is the square root of 1, right? Well, that means that the square root of 10 would have to fit somewhere between 3 and 4. Okay, because 10 is in between the square root of 9 and the perfect square of 16. Do you agree with me? Well, the square root of 9 is 3, the square root of 16 is 4. That means the square root of 10 has to start with a 3. And isn't 10 a lot closer to 9? So we know it starts with 3. We know it's closer to 3 than 4 because 10 is so much closer to 9 than 16. So now what we would do is we could start guessing. So with our calculator, we would start squaring numbers. 3.3 times 3.1, I mean, what am I saying? 3.1 times 3.1 or 3.1 squared is 9.61. Okay, so what about 3.2 squared? 3.2 squared is 10.24. So we went over a little bit, right? Which means the square root of 10 is somewhere between 3.1 and 3.2. So I would estimate it to be around 3.1. Okay, now one great thing about these calculators is you can figure out what the square root of 10 is by just plugging it in your calculator, hitting the double arrow button, and your calculator tells us the answer is 3.162277. So. All right, so we got pretty close by estimating about 3.1, between 3.1 and 3.2. So if you didn't have a calculator, this helps you estimate the approximate value of non-perfect squares. This is a great skill to have even if you have a calculator, okay? So for example, what about the square root of 20? Between what whole numbers would I find the square root of 20? Well, it comes between what two perfect squares? Well, square root of 20 would be in here, right? So it'd be between square root 16 and square root 25. Well, the square root of 16 is 4. Square root of 25 is 5. So it's going to start with a 4. It's going to be between 4 and 5. It's almost right in the middle, but it's a tiny bit closer to 4 than 5, or 16 to 25, isn't it? So I would probably start guessing around 4.4. So I wonder what 4.4 squared is. It's 19.36. So 4.4 squared is 19.36. And then let's try 4.5 squared. Just see what that is. Well, that's 20.25. So we know that the square root of 20 is between 4.4 and 4.5. And my calculator tells me that it's really 4.47, which is what we estimated it to be. So this is great practice. Like I said, even if you have a calculator, you should be able to approximate the square root of non-perfect squares. All right, so where would 150 fall on this list over here? It's between what two perfect squares? Well, be right there, right? So 150 is falling between 144 and 169, which means it's between what two whole numbers? 150, the square root of 150 is between 12 and 13 because it's between the perfect squares of 144 and 169. So I know it starts with a 12. It would be closer to 12 than 13 because 150 is closer to 144 than 169, right? So I would start estimating around 12.12. And then finally, where does square root 50 fall here? Square root 50's got to be really close to the square root of 49, doesn't it? So I would think that it would be very close to probably 7.1. So let's see what 7.1 squared is. Yep, it's 50.41. So it's even a little bit bigger. 7.1 squared is a little bit more than 50. So we could even try something like 7.08 or something like that. Okay. So your calculator will, like I said, give you the first few decimals. So it's actually 7.07. So we got really, really, really close. So that's how you estimate perfect squares. You estimate perfect squares. Now we also will talk about perfect triples, not so much, and these numbers get large fast. So basically it's asking me what is the cubed root of 125? In other words, what number times itself 3 times? And of course our chart tells us it's 5. 5 times 5 times 5. So 5 times 5 is 25 and 25 times 5 is 125. So you would say the cube root of 125 is 5, the cube root of 125. What about the cube root of 8? Well, the answer is 2. 2 times 2 times 2 is 8. Now here we have a cube root and inside we have a negative number. Well, I agree that the cubed root of positive 27 is 3 because 3 times 3 times 3 is 27, right? Well, let's see if we can get a negative 7. Let's see if we can get a negative 27. Well, let's try negative 3. Negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 is positive 9, and 9 times negative 3 is negative 27. So this is a real solution. It's real. The cube root of negative 27 is negative 3, okay? If it's a square root of a negative number, you get no solution. But real answers come from the cube root of negative numbers. All right, and one more, we'll look at this one. So even though there's a fraction in there, you can still think of this. You can divide that in your head. You can divide it. You can write it out on your paper and say, okay, well, let's see what the cube root of 1 is. What number times itself 3 times is 1? The cube root of 1 is 1. And the cube root of 64 is 4. So the cube root of 1 over 64 is 1/4. That is the answer. All right, so that's a quick lesson on perfect cubes. All right, so look at this problem. It says identify square root 3 as either rational or irrational and approximate to the 10th place. Well, first of all, it's the square root of a non-perfect square, which automatically makes it irrational. So we're going to throw this one out and we're going to throw this one out. It's definitely irrational. So then the next thing I would do on my calculator is I would multiply 1.7 times itself and I get so let me write it down. So 1.7 squared is 2.89. And then it wants me to try 1.8. Well, 1.8 squared is 3.24. So which one's closer? This one's 0.11 away and this one's 0.24 away. So I would go with this answer. okay? 1.7 squared is a little closer to 3 than 1.8 squared. And then this one is a good question. The area of an artist's canvas can hold 133 square inches of paint. All right, so we have an artist canvas, and we know the area is length times width, right? And I think I left off the name. I think it said the area of an artist's square canvas. Well, what's true about squares? The side lengths are the same, right? So we want to know what number times itself. Since it's length times width, we would take a number and multiply it by itself. We want to know what is the closest number one side length would be that when we square it, we get 113. Well, this is a multiple choice question. So what I would do on my calculator is I would type in 10.62 and square it, and I get 112.78. I would type in 10.63 and square it. I get 112.996. That's really close. 10.64 squared is 113.2096, and 10.65 squared is, we're getting farther away, right? So which of these numbers is closest to 113? This one, right? If we only had 113 square inches of paint, this one would need more than 113. Right? I could fill up my canvas with this, but this is the closest answer, letter B. And I got that by just guessing, testing, right? I just put it in my calculator. All right, you guys, that's it. So that's all. You only have those 2 sections to do this week, and then you have 2 days to work on a Delta math assignment. So not too much going on this week. So anyway, I hope you guys have a good week. And if you need me, reach out to me and I will get back to you as soon as I can. Okay, see you later.